All right, let's jump right into this explainer. Today, we are tackling one of the absolute highest stakes challenges in the tech space right now: how to actually deploy AI agents in heavily regulated industries without causing a catastrophic failure. We're skipping the hype completely. Instead, we're going to look at the exact operational framework you need to put autonomous agents into production environments where a single mistake could literally cost millions of dollars, or worse, completely violate federal regulations. Here is our roadmap. We'll start with the Agentic Workflow Challenge, map out the 3 tiers of automation, cover how to guard against AI failure, walk through 2 real-world case studies on eligibility screening and protocol triage, and finally wrap up with how to defend the automation boundary.
Okay, Section 1, the Agentic Workflow Challenge, setting the stakes at Helix Therapeutics.
To set the stage, we're dropping into Helix Therapeutics. They're a $1.4 billion biotech company, and their VP of Clinical Operations, Dr. Ayanna Brooks, has just handed down a massive mandate. She wants 3 critical oncology trial workflows to become agentic in the next 2 quarters. The pressure is absolutely on, and FDA scrutiny is, as you can imagine, intense. Now, when faced with a mandate like that, we see a massive rookie mistake right out of the gate. People assume a workflow has to be either completely automated or completely manual. It's this incredibly flawed agent good versus agent bad mindset. But the correct mindset, the one that actually survives contact with real-world operations, is placing an automation boundary step by step. You don't just automate a whole workflow, you automate specific stages of it. Moving to Section 2, 3 tiers of automation, defining the operational vocabulary. To figure out exactly where to place those boundaries, we use the canonical Sheridan-Verplank scale. Fun fact about this, it was actually developed at MIT, originally to keep undersea robots from doing anything totally crazy down in the ocean. For our day-to-day operations, it compresses nicely into 3 operational tiers based entirely on what the humans do when things go wrong. Our first tier is human in the loop, or HITL. This is the lowest level of automation. The agent might suggest an answer or sift through a mountain of options for you, but it's not taking action. The human is the absolute, unquestioned gatekeeper here. Without a human explicitly saying yes, the workflow stops dead. Next up, we have human on the loop, or HOTL. This right here is the sweet spot. It's where most successful long-term production workflows actually live. In this tier, the agent is deciding and taking action, but a human is actively monitoring the whole system. The human acts as an override. Think of it like they have their foot hovering right over the brake pedal, ready to veto an action before any irreversible damage is done. And finally, there's human out of the loop, or HOOTL. This is full autonomy. The agent decides, acts, and it's totally consequential before a human can even intervene. The human is basically just a post hoc auditor, meaning they're just reading a summary of what the AI already did, way after the fact. As you can guess, the regulatory risks here are absolutely immense if you place this tier on the wrong step. So here's the real secret to making this work. A single workflow is not a monolith. Using the famous Parasuraman 4-stage model, we can slice a task into 4 distinct pieces: acquiring the data, analyzing that data, making a decision, and implementing the action. And this is crucial. You can, and absolutely should, assign completely different automation tiers to each one of those 4 stages. Let's move to Section 3, guarding against AI failure, identifying vulnerabilities at the boundary. We have to talk about what happens when operational reality hits, because these boundaries don't just stay where you put them. They naturally get pushed backward, toward human judgment. There are 5 characteristic ways these boundaries fail, but I want to zero in on the absolute most dangerous one: silent confidence. This is terrifying. It's when an AI model hits a rare edge case input, gets the answer completely totally wrong, but is highly confident in its wrong answer. Because it's confident, no alarms go off. The human has zero clue that a massive error is just quietly happening in the background. To prevent silent confidence from destroying your project, you have to enforce the load-bearing rule of agentic design. If your agent is on the loop or out of the loop, it absolutely must have a strictly defined trigger. In writing, we call this a deferral signal. It could be an out-of-distribution detector, something that spots when the AI is looking at a prompt it's never seen before, or it could just be a strict mathematical confidence threshold. But the moment that signal trips, the agent is mathematically forced to hand the reins back to a human. Without a named deferral signal, your workflow is literally just silent confidence wearing a process diagram.
All right, Section 4, Case Study on Eligibility Screening, Evaluating Phase 3 Trial Candidates.
Let's make this totally concrete and apply it directly to Helix Therapeutics. Their first workflow goal is using an AI agent to read messy patient referral records from hospitals and then flag candidates who might actually be eligible for a massive Phase 3 oncology trial. Now, rather than just yelling, "automate it," we decompose this massive headache into 4 distinct steps: pulling the electronic health records, parsing those really messy clinical notes, scoring the patient data against strict trial criteria, and finally, surfacing the candidate to a recruitment coordinator. This is where it gets brilliant. Look at how the automation actively shifts throughout the workflow. For the really heavy lifting, acquiring and parsing the data, we keep the automation high. But pay attention to that scoring step. If the AI's confidence drops into the bottom 15%, boom, it triggers a forced human-in-the-loop review. And for that final step of actually contacting the patient, we use a hard structural block. The AI is literally never allowed to contact a patient directly. FDA and good clinical practice regulations are way too strict for that. The human coordinator absolutely must be the one to press send.
Moving right along to Section 5, Case Study on Protocol Triage, Classifying Clinical Site Deviations.
For Helix's second workflow, Dr. Brooks needs an agent to process site queries. Imagine a clinic reports that a patient missed their required blood draw window by 3 days. The system has to read that unstructured query and immediately route it based on whether it's just a minor hiccup or a deeply critical trial deviation. Again, we decompose it, parse the query, classify the severity, file the minor issues straight into the trial master file database, and specifically route the dangerous ones to the medical team. The boundary placements we do here are super fascinating. Check out step 3. We actually let the agent act totally out of the loop, just filing minor logs completely on its own. Why? Because the regulatory risk of a minor log is practically 0, and the error rate is tiny. But contrast that with step 2. If the AI ever tags a deviation as critical, it triggers an immediate, forced human-in-the-loop review by a medical doctor. And for the routing step, if the issue just sits untouched for 24 hours, an SLA breach, it forces an alert. This guarantees we don't accidentally bury a major medical issue under an algorithm, avoiding a catastrophic compliance failure.
Okay, final section. Section 6, Defending the Automation Boundary, the ultimate test of agentic scoping.
We've arrived at the most hotly contested workflow at Helix, source data verification, or SDV. This is the painstakingly tedious process of matching database entries against original scanned medical documents. Because it's so tedious for humans, the temptation to fully automate it is huge, but it's a trap. SDV is bound by 21 CFR Part 11, which is the FDA's incredibly strict law on electronic records. If an AI makes a mistake here, it creates a legally binding, permanent audit trail consequence. Putting an AI totally out of the loop on this step sends your regulatory exposure straight through the roof. So how do you survive that kind of intense FDA scrutiny? Forward deployed engineers use something called a boundary placement memo. Notice how we keep SDV way down at the assist tier. That's specifically designed to guard against an accountability gap. Every single automated step across all these workflows is paired with a written deferral signal and an assigned human owner. When the signal trips, that specific human is responsible. Honestly, whether you're in biotech, finance, or just standard software, you should start borrowing this memo format right now. It is exactly what keeps you from taking the fall for an AI hallucination. That brings us to our final thought, the ultimate safety net. Before you launch any AI workflow, you have to ask yourself one question. What is your exact mathematical pre-commitment to roll back automation to a human before a silent failure takes down your multi-million-dollar project? If you don't know the exact threshold that forces a rollback, you simply aren't ready to deploy. Think agentically, place those boundaries carefully, and I'll see you in the next explainer.